10.3, solving logarithm and exponential equations. So we've already messed around with the properties and changing forms and stuff. So now we're going to solve these logarithmic and exponential equations. A lot of the reasons we use logarithms is to be able to solve exponential equations. So that's like when the variables are up in the exponent. It makes it a little tough to solve these. So now, let's look at these first ones. So these are when there is a common base. So that means I can somehow change this 125 so that it has a base of 5. So 125 is 5 to some power. I just need to figure out what that power is. So the way I'm going to do that is I'm just going to start with 5. And I'm going to do 5 times 5, which is 25. I'm not to 125 yet, so I'm going to times 5 again. So I'm going to go 25 because I just take that, and then times 5. That equals 125, which is what I was trying to get to. So there's 1, 2, 3 5s right there. So this is the same thing as 5 cubed. And you can put that in your calculator and see that you will get, you'll get 125. So 5 cubed is 125. Okay, so that means 5 to the power of x equals 5 cubed. And since these bases are the same, now I can just set the exponents equal to each other. So that is x equals 3. And then the x is by itself, so we're done. Okay, let's look at this one. So this is 4 to the power of 2x plus 1 equals 1024. We need to get a common base. So this, 1024, is 4 to the power of something. We don't know what that is, so it's 4 to some power. We need to figure out what that power is. So let's just do it the same way I did it over here. So I'm going to go 4 times 4. 4 times 4 is 16. We're not to 1024 yet. So then I'm going to go 16 times 4, which I'll just put my calculator right here. You guys can see. So 16 times 4 is 64. Still not there yet. Okay, now I'm going to go 64 times 4. So 64 times 4 is 256. Still not there. So then I'm going to go 256 times 4. Whoops, times 4. That is 1024, which is what I wanted. So I have 1, 2, 3, 4, 5 fours. So that's 4 to the 5th power. And you can always double check. 4 to the 5th is 1024. So that's exactly what I was looking for. So now my bases are the same. I'm just going to set my exponents equal to each other. So that's going to be 2x plus 1 equals 5. Then I just solve for x. So I subtract the 1. 2x equals 4. Divide by 2. So you'll get x equals 2. And that's your answer. Okay, now let's look at solving them without a common base. So this is where we're really going to use logarithms. And you could solve these top ones the same way we solved the bottom ones if this all didn't make sense to you. I would strongly encourage you, if it doesn't make sense, to go back and rewatch that part to try and make it make sense, because that's a good skill to have, to be able to solve those that way. So now we're solving these without a common base. And 3 never raises. You can't raise 3 to a power and get 17. It just doesn't work. So I'm going to change this into a logarithm. And remember, when we change it into a logarithm, you can make that L. So that's going to be log base 3 of 17 equals x. Okay? Then right here, so my x is by itself over here. I can solve this side of the equation using the change of base formula. So that's going to be log of 17 over log of 3 equals x. So now I just need to put this in my calculator. So I'm going to go log 17 divided by log of 3, and I get 2.578. So x equals 2.57. It's actually 9 because that 8 would round up. So that's what x equals, and that's how I solved that equation. I solved it by changing to a logarithm. So when you're solving an exponential equation without a common base, you have to change from an exponential equation to a logarithmic equation. Okay. Now let's look at this one. This one's going to be a little bit more tricky, but not too bad. So first, let's change it into a logarithmic equation. So I'm just going to use my L again. So that's going to be log base 8, because that's the first number I hit, of 26 equals y minus 3. Okay. So here, let's use change of base again. I'm just going to put COB. So change of base. So that's going to be log of 26 over log of 8 equals y minus 3. Now let's put this part into my calculator. So that's going to be log 26 divided by log of 8, 1.567. So this will be 1.567 equals y minus 3. And then my last step is to get this y by itself. So to get that y by itself, I'm going to add the 3 over. So plus 3, and then I'm just going to come up here. So that's y equals 4.567. Okay. Now let's look at solving a logarithmic equation. So if we're solving these logarithmic equations and they have the same base, we have the same base here, then it's super, super easy. If you have the same base, it's super easy. All you do is set this middle part equal to each other. So this is going to be negative 3v minus 1 equals 5v plus 7. And then you're just going to go through and solve for this equation. So I'm going to move all my v's to one side and all my numbers to the other side. So I'm going to add 3v right here, add 3v. So that's going to be negative 1 equals 8v plus 7. Then I'm going to subtract the 7. So I'm going to come up here. Negative 8 equals 8v and divide by 8. So that's v equals negative 1. And you're done. That's all you have to do. So if these are the same, if the bases are the same, you just set that equal to each other. Okay, let's look over here. So now we don't have a logarithm on this side. We don't really have any sort of way to do anything until I change this into an exponential equation. So when you're solving a logarithmic and it's like this first, you're going to change to an exponential. So I'm going to change to an exponential equation. And remember, if there's not a number right here, you assume that it's 10. So now if I change this to an exponential, I can use my e. So that's going to be 10 to the 1/2 power equals 2x plus 1. Okay, so let's put 10 to the 1/2 power just in our calculator and see what we get. So 10 to the 1/2, you get 3.162. So 3.162 equals 2x plus 1. Then I'm just going to solve for x. So I'm going to subtract the 1. I'm running out of room. So that's going to be 2.162 equals 2x. Then the last step is to divide by 2. So I'm going to divide this by 2, divide that by 2. So you get x equals 2.162 divided by 2, 1.081. Okay. I know this is a ton of information I'm just kind of throwing at you. We're just solving equations here though. So if you're confused, I would go back and rewatch, like say you were confused up here on the exponential part, go rewatch that one. If you're confused on this one, just go and rewatch that one, okay? So let's do this last one. So we're using logarithmic properties to solve an equation. So first, this is a plus right there, which means this is the product property. And remember, the product property, you multiply these together because they have the same base, so you're going to multiply those together. So this is going to be log, and there's nothing there, so we just assume it's a 10. You don't have to write it, though. Then that's going to be x plus 9 times x equals 1. Okay, then let's just distribute this x in. So that's going to be log of x squared plus 9x equals 1. Okay, now we're going to change to an exponential. So right here I'm changing to an exponential. And there's no number right here, so I assume it's a 10. So that's going to be 10 to the first power equals x squared plus 9x. And this looks like something we've done before. We have a squared, we have a regular variable, and a constant. When you have those three things, you have to factor it. And in order to factor, we have to set it equal to 0. So we're going to factor, and we're going to set equal to 0. So I'm going to subtract the 10 from both sides. So I'm going to get 0 equals x squared plus 9x minus 10. And I'm going to come right up here. Okay, and to factor this, I'm going to use the big magic x thing. So the top number is the first times the last. So that's 1 times negative 10, which is negative 10. The bottom number is 9. So I have to see what multiplies to be negative 10 and adds to be positive 9. So I'm going to write down my factors of 10. So that's 1 and 10. 1 and 10, if I do 1 minus 10, that will equal 9. Just one of these has to be negative. It's going to be a negative 1. So this is going to be negative 1 and positive 10. Okay, so then up here, that's going to be 0 equals x minus 1. X plus 10, and we're not done solving yet. We have to set each individual one equal to 0. So that'd be x minus 1 equals 0, x plus 10 equals 0, so x equals positive 1 and x equals negative 10. Okay, hint, when you have two answers, it is normally the negative answer that does not work. But we are going, let's just double check these answers, okay? So let's plug this in. So if we have log and x equals 1, so that's going to be 1 plus 9 plus log of 1 equals 1. So that answer is good. So this answer checks out. We're good. Now let's try the negative 10. So I have log negative 10 plus 9 plus log of negative 10. Not a real answer. That means this one does not work. So this is our only answer for that one. Okay. Let's do this last one. So this is a subtraction, which means this is the quotient property. So this is going to be log of 6 over 3x equals negative 2. Okay, there's not a number here, so we assume it's a 10. I hope you're catching on to when there's not a number there, you assume it's a 10. So that's going to be, then I'm going to change this to an exponential. So this is going to be 10 to the negative second power equals 6 over 3x. Okay, now let's just solve this. So first let's start with solving on this right side. So 10 to the, whoops, oh, you can't even see it. You still can't see it. 10 to the negative second is 0.01. So this is 0.01 equals 6 over 3x. Then I want to get rid of my fraction here. So I'm going to multiply both sides by 3x, multiply by 3x. So this is going to be, so 3 times 0.01 is 0.03. X, these cancel over here, equals 6. And then to get that x by itself, I divide by 0.03. So I'm going to get 6 divided by 0.03 is 200. So x equals 200. And it's never a bad idea to just go back and check this. So I'm going to go log of 6 minus log of 3 times 200. And I get negative 2, so that is correct. Put a little box around that. Okay. If you have any questions, come before school and ask, or make sure you ask them at the beginning of class tomorrow. Okay. I'll see you guys later. Make sure you take the quiz.